All right, in this section, we are going to talk about the binomial distribution, but there are a couple of things that we need to talk about before we get there. So, the first one is factorials. And so, the factorial of a positive integer is denoted by that number with an exclamation point, and it is the product, the multiplication of the first k positive integers. Okay, so here's the formula for it. You would just, whatever k is, you just multiply all the numbers together all the way down to 1. Okay. Also, 0 factorial is defined to be 1. Now that may seem odd to you, but it just helps with some of the formulas that we have to deal with. It makes them a little easier to work with if we just use this definition, and it doesn't really take away from anything. All right, so we have 0 factorial. If you see that in an expression, we know that's 1 by definition. Then 1 factorial would be just 1 again. 2 factorial would be 1 times 2, which just comes out to be 2. 3 factorial would be 1 times 2 times 3. That comes out to be 6. 4 factorial would be 1 times 2 times 3 times 4. So that comes out to be 24 if you multiply all that together. And so on and so forth, right? 5 factorial is 1 times 2 times 3 times 4 times 5. So that is 120 if you multiply all that together. And it just keeps going, okay, like that. All right, so that's what the factorial is. So we've already calculated all these out. And what we really need to use the factorial for is something called the binomial coefficient. So if n is a positive integer and x is a non-negative integer, so it can be 0. Oops, actually there's a typo here. That should be an x right there. Okay. Or actually, this is the standard way to do it. So down in this formula, it should be a k. So let me write that out here, and I'll have to go back and fix that typo. All right, so n choose k, or the binomial coefficient nk, is written like this. So it's n factorial over k factorial times n minus k factorial. All right, and so the symbol for it is n over k. There's no fraction bar in here, and there's just parentheses in here. And it's defined to be this expression. And we're going to need this to be able to calculate this expression a little later. So we're going to calculate it out by hand, and then I'll show you how to do that on Desmos. Okay, so let's go ahead and calculate these values out. So we want to do 4 choose 1, 6 choose 3, 8 choose 4, and 3 choose 3. Okay, so to calculate out 4 choose 1, right, you're going to have 4 factorial using this formula right here. So whatever the top number is, factorial on the top. And then k factorial, the bottom number, 1 factorial. And then n minus k factorial. So n minus k, that would be 4 minus 1 factorial. Okay. And then we would calculate that out. We already calculated out 4 factorial before, right? We said it was 24. And then 1 factorial is just 1. Inside the parentheses, we have 4 minus 1, which is 3. So that would be 3 factorial. So that would be 24 times 1. 3 factorial is 6, right? So we have 24 over 6. All of that comes out to be 4. Okay. All right, and it's fine to calculate it that way until the numbers get a little bit larger, and then it's not as nice to do it that way. So for instance, if we have 6, choose 3, and that's another way of saying this. So that would be 6 factorial, right? The top number factorial. And then the bottom number factorial on the bottom, and then 6 minus 3 factorial. All right, the factorial numbers, they get pretty large in a hurry, so making computations with them this sort of way that we did it here with larger numbers is not as easy to do. So when you do this by hand, one of the things that you could do is, instead of multiplying all this out, just write it out, right? 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Right, that's the definition of 6 factorial. All right, and then 3 factorial is 6, we know that. And then 6 minus 3 would be 3 factorial. All right, and then you can start canceling some common factors here, right? All of this is multiplication, right? And we can cancel common factors between the top and the bottom. So here 6 goes into itself once. It goes into 6 once. All right, so on top, right, we have 5 times 4 times 3 times 2. I'm really not going to bother to write the ones, right, because 1 times anything is just itself. And down here, right, in the bottom, I have 3 factorial times 1, so I'm not going to worry about the 1. 3 factorial is 3 times 2, and again, times 1, right, but again, that 1 is really not going to affect, right, anything, so I am going to not write it. And then I can see I have a couple of other common factors in there, right? I have this 3, that cancels with this 3, this 2 cancels with that 2. So I'm left with 20 on top and a 1 on the bottom, so this comes out to be 20, okay? So you don't have to multiply it all out like we did up here. You can just kind of write this out and do it that way. All right, let's take a look at the next one. All right, here we have even bigger number to deal with, 8 factorial, right? On the bottom we have 4 factorial. And we have n minus k, so the top number minus the bottom number. Factorial. All right, so that is 8 factorial over 4 factorial times 4 factorial. So we have 1 4 factorial from here, and then another one 8 minus 4 4 factorial here. All right, and I showed you a shortcut so you don't have to multiply a bunch of stuff out if you're doing this by hand. But even that is actually too much, right? And the key observation here is that I could have just stopped right here, you see, and just wrote 3 times 2 times 1 as 3 factorial up in this example. And that matches this, and then those are 2 factors, and I could have canceled them out. So even what I did up here, I can shorten that up a little bit, right, by doing this. 8 factorial would be 8 times 7 times 6 times 5 times, and then at that point, right, I could write 4 times 3 times 2 times 1, but if you think about it, 4 times 3 times 2 times 1 is just 4 factorial, right? And so I can cancel this 4 factorial with one of those there. So you can see that's even shorter than what I did before. All right, I still have to do some work here, right? I still have 1 4 factorial that needs to be canceled out, so I can write that as 4 times 3 times 2. Again, not really writing the 1 there. And then do some canceling, right? So 3 times 2 is 6, right? And I have a 6 up here, so that 3 and the 2 can be canceled with this 6 up here. And then 8 and 4 have a common factor of 4, right? So 4 goes into itself once, it goes into 8 2 times. So we're going to wind up with 2 times 7 times 5, right, on the top, and a 1 on the bottom. And so that comes out to be 70, right, when we do that. All right, and then this last one here, 3 choose 3, right? When we do that, we get 3 factorial on top, 3 factorial on the bottom, and here we get 3 minus 3 factorial. So on the top, I have 3 factorial, and here I have 0 factorial. All right, so you can see I already have 2 factorials, and I can just cancel those out, right, and put 1s there. And then 0 factorial is 1 itself. So I get 1 on top, and on the bottom I get 1 times 1. So that just comes out to be 1 in that case. All right, so that's how you would compute those things by hand. You can see it's kind of a pain to have to do that. So in Desmos, it provides an easy way to do that. To do that, you would do NCR like this. And then in parentheses, you would put the top number. So the first example we did was 4 and 1, right? So 4 and 1. Oops. You can see that comes out to be 4, right? Just like we had over here. Side by side, so it's a little easier to look at. All right, this example, n choose 3, NCR, we have 6 comma 3, right? That came out to be 20, just like we did here. 8 choose 4, so NCR 8 comma 4, 70. And then NCR 3 comma 3 comes out to be 1. Okay. By the way, I remember when we were talking about the definition of factorial, I said it makes making 0 factorial equal to 1 makes these formulas easier, and here's a situation where you have that. If we had defined this to be 0, well then this expression would be undefined, which would be kind of a pain. We kind of want it to come out to be 1 here for reasons that I won't go into. Okay. All right, so that's how to calculate the binomial coefficients by hand and doing it on Desmos. A lot of calculators, a scientific calculator will probably have a button on there too as well if you're using something else to do that. Okay, so that is a good stopping point for this first video. In the next video, we are going to talk about a specific kind of experiment called Bernoulli trial.